The Sea Harrier is a single-seat aircraft, and the pilot, in addition to flying the machine throughout its unusual flight envelope, has to perform many of the functions that are normally carried out by an observer. In order to assist him, flight data is provided by the head-up display, also known as the pilot's display unit. Flight, navigation and weapon aiming data is provided by electronically generated green symbols that appear superimposed on the outside world when the pilot looks through the windscreen. Principal data sources are the NavHARS and Blue Fox radar. The weapon aiming computer, or electronic unit, processes the data and generates the symbology for the head-up display. The HUD system comprises 3 LRUs. The pilot's display unit contains an optical module and an electronic module. An electrostatically focused CRT and its deflection system is contained within the electronic module. Located in the rear equipment bay is the electronic unit. This contains a digital computer and a 20K word core memory. Facilities are available for loading the unit's reprogrammable core memory at first line. This enables program changes to be carried out without removing the unit from the aircraft. Conveniently located on the port side of the cockpit is the pilot's control panel. This controls all the mode and symbology functions of the pilot's display unit. Before examining the different modes of operation in more detail, it is necessary to look at the HUD system in relation to the remainder of the NavAttack system. The head-up display weapon aiming computer system is one of 3 elements of the overall NavAttack system. The second element comprises the Blue Fox radar. This is a high-performance, I-band, pulse-modulated, frequency-agile radar which operates in both air intercept and surface search and strike modes. Although it comprises a total of 9 LRUs, only 4 are shown in the simplified diagram. The head-down display, in addition to displaying the radar picture, also shows flight information, so that the pilot can monitor aircraft attitude whilst viewing the radar. The third element is the navigation, heading and attitude reference system known as NavHARS. This subsystem is based on its own digital computer contained in the electronic unit Navigational. It has its own control and display unit, which is known as the Display Navigational Control. Principal navigation sensors are an inertial platform, Doppler, TACAN and a magnetic flux valve, whilst air data derived from the pitot-static system is available from the air data computer. In addition, radar altitude data is available to the weapon aiming computer directly from the radar altimeter. The link between the weapon control panel and the weapon aiming computer enables different weapon delivery modes to be selected and makes provision for automatic weapon release and firing. The 3 main subsystems, the HUD, the radar and the NavHARS, are linked together by digital data transmission links. At a bit rate of 64 kHz, data such as radar target range, aircraft heading, barometric height and aircraft attitude will be interchanged and updated, weapon aiming information computed and a wide variety of displays generated. The general concept of the NavAttack system has now been dealt with, and in part 2 we will deal with the basic modes of operation and the generated displays. In part 1, we saw the general concept of the head-up display, and now we will look at the basic modes of operation. This mode can be used for takeoff, but will normally be used for landing only. To select it, power is made to the HUD wax system by making the HUD on switch, and the mode is selected to VSTOL on the mode selection switch. The VSTOL display now appears on the pilot's display unit. These symbols are projected onto the combiner glass through which the pilot views the outside world. The symbols are green and focused on infinity. Brilliance is initially set by means of the brilliance control adjustment on the PCP. Thereafter, an auto brilliance system will make adjustments as the ambient light level varies. At the top center of the display is the barometric pressure indication. This is set up by a knob on the pilot's control panel. The barometric pressure of a required location can be inserted so that the barometric height can be measured with respect to that location. This adjustment is independent of the QFE adjustment on the head-down altimeter, although normally for landing they would of course be set for the same pressure. Any large differences between the head-down and the head-up barometric altitude displays can be minimized by the adjustment of the millibar trim potentiometer located in the WAC. Both head-down and head-up instruments derive data from a common pitot-static system and air data computer. The head-up data is, however, additionally processed by the WAC. Aircraft attitude is indicated by pitch bars which are 5 degrees apart and are always parallel to the real horizon. Angles above the horizon are shown with solid lines, whilst those below are dotted. Angle values are shown at the ends of the bars, which also have feet that always point towards the horizon. Aircraft attitude is also indicated by the head-down attitude indicator, which is a self-contained gyro instrument. On the right of the display, vertical speed is indicated. The rate of climb or dive is shown in feet per minute, and the divisions shown are plus or minus 500, 1000, 2000 and 4000 feet per minute. Directly below the vertical speed indication is the height digit display. Height in feet is shown in 20-foot steps up to 10,000 feet and thereafter in 50-foot steps. This indication may be either barometric or radar height, selectable on the PCP. The radar altimeter is only valid up to 5,000 feet. Radar altitude is prefixed by the letter R. This symbol will flash when the radar altitude is selected but not valid. Situated on the left-hand side of the display is the angle of attack indication. This indication is derived from the airstream direction detector. The airstream direction detector probe is mounted on the starboard side of the front fuselage. The airstream direction detector indicator is repeated in the head-down cockpit display. Full-scale deflection is approximately 25 units in the Sea Harrier, but for practical purposes The units are equivalent to degrees. Immediately below the angle of attack indication is the digital speed display. This indicates airspeed in knots, or when selected on the pilot's control panel, Mach number. Both airspeed and Mach number are shown on head-down instruments. The Mach number is displayed in digital form. Across the bottom of the display is the heading scale. This shows a range of angles 15 degrees on either side of the course being steered, which is indicated by the heading marker at the centre of the display. The heading display is derived from the Navhar system and may be either magnetic or true, as selected on the display navigational control. When selected to magnetic, an M is displayed at the left of the heading scale. The circle below the heading scale indicates lateral acceleration or side force. The circle moves between the vertical lines and works in the same sense as the conventional slip indicator. Data is derived from the side force sensor, and with the circle just touching the vertical lines, the lateral acceleration is 0.06 g. The aircraft symbol remains in the centre of the display, and in this mode is at 6 degrees below the aircraft's longitudinal fuselage datum and shows aircraft attitude. In some other modes, the aircraft symbol will be displayed without its legs and 2 degrees below the longitudinal fuselage datum. This is a matter of selection on the PCP and is not in any way a function of undercarriage selection. Having dealt with much of the basic flight symbology, other symbols introduced in other modes of operation can now be examined. The launch mode is selected by the mode selection switch on the pilot's control panel. The launch Y markers are displayed at 6 degrees above the horizon. By flying in such a way that the aircraft symbol, which is at 6 degrees below the aircraft longitudinal fuselage datum, lies between the Y markers, the aircraft's attitude is established at plus 12 degrees, the optimum attitude during launch. At the bottom right-hand corner of the display is the altimeter clock. The digital display moves in 20-foot steps and the pointer in 100-foot steps. The climb and dive symbol, an inverted triangle, indicates the aircraft's vertical flight path, but is inoperative in the launch mode. This display is generated whenever the air-to-air mode or air-to-ground mode is selected on the pilot's control panel, provided no weapon has been selected. Note that the aircraft symbol has lost its legs and gained a fin. In this mode it is positioned 2 degrees below the longitudinal fuselage datum and provides, in conjunction with horizon and pitch bars, an indication of aircraft attitude. The climb and dive symbol now gives a true indication of the vertical flight path. The side force symbol has been replaced by a steering demand symbol. This indicates the steering demand to a waypoint which has been selected as a destination for steering on the display navigational control. The number below the steering demand indicates the waypoint selected for steering. If the steering demand is more than 15 degrees away from the current heading, the symbol is placed at the extreme left or right of the scale. It will move towards the heading marker when the aircraft turns towards it and reaches the demand. The steering demand may also be in the form of a letter U, signifying UHF, when homing is required to a received station. That completes the basic modes of operation. Part 3 will illustrate the essentially dynamic nature of the display, with a simulated short takeoff, flight and a pilot's interpreted approach and landing. The following sequence, filmed on the Sea Harrier simulator at British Aerospace Limited Hatfield, will show the dynamic characteristics of the head-up display. A simulated short takeoff, flight to waypoint 2 and land on at waypoint 1 using pilot's interpreted approach, or PIA, will be demonstrated. The pilot has selected launch on the PCP and is lined up at the end of the runway. IAS is 0, although 60 knots is indicated. The aircraft accelerates down the runway and at 135 knots the pilot eases back on the control column and the aircraft becomes airborne. Throughout the sequence, note the constant alterations which occur in pitch, roll, rate of climb and dive, altitude, angle of attack and IAS. Air-to-air is selected on the PCP and waypoint 2 on the DNC. The waypoint 1 symbol changes to waypoint 2 and is repositioned. The aircraft is now climbing at over 4,000 feet per minute and the IAS is increasing. The pilot now steers for waypoint 2. But will turn to starboard and then to port to demonstrate the movement of the waypoint 2 symbol. The aircraft is banking to starboard, so the waypoint 2 symbol moves left along the compass card, because waypoint 2 will now be to port of the aircraft. The aircraft is now banking to port and turning into waypoint 2, so the waypoint 2 symbol now moves right. A full 360-degree roll to starboard will now be carried out. Note that the legs at the end of the pitch bars always point towards the ground. A half loop with the roll off the top will now be shown, and again note that the legs at the end of the pitch bars always point towards the ground. The aircraft is now carrying out a full 360-degree loop. The pitch bars are always unbroken while the aircraft's nose is above the horizon, and always broken when the aircraft's nose is below the horizon. The pilot now selects waypoint 1. This appears momentarily at the same position as waypoint 2 before taking up its correct position at the right hand side of the display. The aircraft is turning to port away from waypoint 1, and when the aircraft has turned far enough, the symbol will appear on the left hand side of the display, and the aircraft continues turning into and past waypoint 1. The height display indicates over 14,000 feet, but the aircraft's height is decreasing. 300 knots plus is indicated on the IAS display, but is also decreasing. The vertical speed indicator to the right of the display shows that the aircraft is diving at over 4,000 feet per minute. PIA is now selected. The flashing N1 at the bottom right of the display indicates that the aircraft's navigational system is valid but not yet in control. When the N1 symbol stops flashing, it indicates that the EUN controls the approach to waypoint 1. The 3 zeros at the top of the display is the QDM. The QFE indication will only be displayed when the millibar trim is depressed. The pilot now uses the inverted V on the compass card to steer a PIA to waypoint 1. At the top left of the display is positioned the track miles to run, shown in miles and tenths of miles. Also shown now is the side force symbol. The flashing cross symbol to the right of the display indicates the direction of the selected destination. The PIA sequence will now move on from 26.3 miles to 12.8 miles to run to destination 1. You will now see that the steering bug is moving right along the compass card, and the pilot is turning the aircraft to starboard to keep the steering bug in the centre of the compass card. The displayed track miles to run is not a line of sight track, but a computed approach taking into consideration all manoeuvres that require to be taken before reaching destination 1. The N1 symbol now changes to a flashing M. This indicates that MAJ is valid, but not yet in range. When it changes to a steady M, it indicates that MAJ is valid and locked in. The small triangle on the height clock at the bottom right of the display is set by the EUN at 1200 feet. This is used to give the pilot an optimum glide path starting point at a height of 1200 feet and at a range of 4 miles. The pilot now uses the steering bug and the height triangle on the height clock to fly down the glide path to destination 1. He follows the height triangle down the scale with the aircraft height pointer. You will see that the cross symbol is steady and almost dead ahead. When the aircraft symbol flashes, this means that the aircraft height is between 280 feet and 230 feet, and the pilot should now be visual and flies the aircraft into the landing site. This completes the introduction to the head-up display and the basic flight symbology. In later films you will see the more specialised weapons displays and examine in more detail other elements of the NavAttack system. The symbology shown is dependent on the software standard, which still remains the subject of development and modification. Thus, for operational purposes, more up-to-date sources of reference should be employed.